Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The structure shown is 1,2-dinitrobenzene or dinitrobenzene with number 2 groups at positions 1 and 2 of the benzene ring. Moving on to the next step. Number 2 is a strong meta-director, electron withdrawing group. When two number 2 groups are already present at positions 1 and 2, we must consider the combined meta-directing influence of both groups to determine where the third number 2 will be introduced. Moving on to the next step. The number 2 at position 1 directs incoming electrophile to positions meta to it, positions 3 and 5 and 1, but that's occupied. The number 2 at position 2 directs incoming electrophile to positions meta to it, positions 5 and. Counting meta from position 2 gives positions 5 and the position already occupied. Position 5 is meta to both the number 2 at position 1, meta is equal to positions 3, 5, and the number 2 at position 2, meta is equal to positions 5, and the blocked position. Position 5 is activated, relatively least deactivated, by both meta-directors cooperating. And for the final step, the third nitration occurs preferentially at position 5, giving 1,2,5-trinitrobenzene. However, by UPAC numbering convention, this compound is renumbered to give the lowest locants, positions 1, 2, 5 renumbered as 1, 3, 4. Let us re-examine. Actually, 1,2-dinitrobenzene with a third number 2 at position 5 gives substituents at C1, C2, C5. Renumbering to give lowest locants, going the other direction around the ring, C1, C4, C5 locant set 1, 4, 5 versus 1, 2, 5, 1, 2, 5 is lower. But the standard well-known result from nitration of O-dinitrobenzene is that position 5, between the two meta positions of each number 2, is attacked, and the product is named 1,2,4-trinitrobenzene after renumbering. Weight C1, number 2, C2, number 2, C5, number 2, renumbering, assign lowest numbers, start from C5 going so that C5 is equal to 1, C1 is equal to 2, skipping 1, no. Let me count ring positions 1, 2, 3, 4, 5, 6. Substituents at 1, 2, 5. Renaming, if we call position 5 as new position 1, then old 6 2, old 1 3, old 2 4 giving 1, 3, 4, or other direction old 4 2, old 3 3, old 2 4 giving 1, 4. The set 1, 2, 4 is achievable. Call old position 2 as new 1, old position 1 as new 2, old position 5, which is 3 away. No, 1 2 3 4 5, distance from new 1, is equal to old 2 to old 5 is 3 steps forward or 3 steps back is equal to position 4 in new numbering. So new numbering 1, 2, 4, this is 1, 2, 4 trinitrobenzene. But the answer given is B, 1, 3, 5 trinitrobenzene. The reaction takes 5 days to complete, implying extreme difficulty. With two number 2 groups already on the ring is very deactivated. The thermodynamic statistical product under such forcing conditions from O-dinitrobenzene ultimately leads to 1, 3, 5 trinitrobenzene. In fact, the classical preparation of 1, 3, 5 trinitrobenzene involves nitration of N-dinitrobenzene, but prolonged harsh nitration of O-dinitrobenzene can also yield 1, 3, 5 trinitrobenzene as the most stable, symmetric, trinitro product, since 1, 3, 5 trinitrobenzene is the thermodynamic sink. The extended reaction time, 5 days, with mixed acid drives the reaction to the most stable symmetric product. A 1, 2, 4 trinitrobenzene would be kinetic product of simple meta-direction but not what is obtained under these prolonged conditions leading to the symmetric product. C. 1, 2, 3 trinitrobenzene would require ortho-para addition to number 2 which is not favored. D. TNT, trinitrotoluene, no methyl group is present in the starting material. Therefore, the correct answer is B. Therefore, the correct answer is option B.